Let's study one of the most interesting sorting methods known as quicksort for implementing data structures. Now, what is a quicksort? The quicksort uses the divide and conquer while not using the additional storage. So that is an advantage of a quicksort, that it does not require additional storage. A quicksort first selects a value which is called the pivot value. The role of the pivot value is to assist with splitting the list. The actual position where the pivot value belongs in the final sorted list, commonly called the split point, will be used to divide the list for subsequent calls to the quicksort. We will see this with an example. Now select a pivot, that is the partitioning element. Here it's the first element. We are presuming that P is the pivot element, which is the first element of the list. Rearrange the list so that all the elements in the first S positions are smaller than or equal to the pivot, and all the elements in the remaining n minus S positions are larger than or equal to the pivot element. So if my pivot gets placed at this position, then all the elements on the left side will be less, that is A of I should be less than or equal to P, and all on the right should be A of I greater than or equal to the P. So all of the right hand side will be larger than the pivot element. Exchange the pivot with the last element in the first, that is less than equal to subarray. The pivot is now in the final position. Sort the subarrays recursively. These can be sorted either using a quicksort or any of the other sorting methods, depends on how the programmer follows it. Now this is the partitioning algorithm for the quicksort. If P is less than R, if the pivot element is less than the R element, then Q partition is A, P and R. Recursive call to the quicksort, we pass the lower part of the array, that is we pass the array, the first position and the pivot element position and the qth, that is where I'm partitioning my array. And recursive call to the quicksort is Q plus R, that is we're adding the right side of my array. Now this is the code for partitioning. Integer partition, void A, the pointer to that array, low and high. Int left and right, which is used for pointing the low and the high. Void pivot element is a function which is called, and the pivot item is equal to A of low, so that value goes in the pivot item. Pivot is equal to left is equal to low, so this low becomes the pivot, that's the first element, and right is equal to high, so rightmost side becomes the highest element. Now while left is less than right, while my left element is less than right, we say move the left while item is less than pivot. So while A of left is less than equal to the pivot element, we keep on doing left plus plus. While my A is less, the element on the left side is less, we keep on doing left plus plus. And while A of right is greater than the pivot element, we do right minus minus. This we'll see actually while implementing an example. If left is less than right, then we swap. So, and right is the final position for the pivot. Then if it is less, then we pass it on to the swap function, and A of low is equal to A of right is equal to pivot element, and then finally we return right. This is how this code actually works. Now this is an example over here. If this is my array, then 54 is my pivot element, 26 is the left, and 20 is the right. Now we'll actually see how this thing works for the quick sort, how my pivot element gets placed as a position where all the elements on the left are less and all the elements on the right are more than the pivot element. Let's take the example of the same array. Now my array is 54, 26, 93, 18, 78, 33, 41, 56 and 20, and we've taken the first element as the pivot element, and the next is the left and the rightmost as the right element. Now we start checking. As 26 is less than 54, we do not do anything, and we do leave it as it is, and then we say left plus plus. As we do left plus plus, you will see the pointer has come to 93. Now we check. 93 is greater than 54. So as 93 is greater than 54, what do? Then we check it. What happens when it is the right value, which is 20? So it is checked 20 is less than 54, which is the pivot element, then we say exchange the values of left and right. So 93 and 20 are exchanged over here. You will see as 93 were here and 20 was here. As 93 is more than the pivot element, it remained fixed. So we check the right, exchange the values of 90 and 23. So my left becomes 20 now and my right is now 93. So now we do right minus minus and left plus plus. So my left has now become 18 over here and right is 56. So what we check again, 18 is less than 54, so there will not be any exchange and left will be incremented by 1, so left becomes 78. And then what we do next, we next check with 56. 78 is greater than 54, so we stop over there, we don't do anything. Now we check for the 56. As we check 56, 56 is also greater than the pivot element. So we do right minus minus. So there will not be any exchange happening between the left and the right over here because 56 is greater than my pivot element, which is 54. So we do right minus minus. So now my right becomes 41. Next, what we need to do is, it is 41 here. So we need 41 is less than 54. So we exchange the values of left and right. 78 and 41 are exchanged. As 41 is less, so this value will come here and this value will come here. So my array becomes this. Pivot remains at 54, 41 and 72 are exchanged. We do left plus plus. So 41 less than 54. So we exchange the values and then left plus plus. So now it is 33 and 78. As we do 33 and 78, what we see next, 78 is greater than 54 and 33 is less than 54. So we've got the position for our pivot element here. So we exchange the value of 33 and 54. So my pivot value has got its final position. You will see we exchange 54 and 33, so it's got the final position. You will see all the values on the left are less than 54 and all the values on the right are more than 54. So this is how my pivot value has got its position. Now to sort these elements using a quick sort recursively, we can again take 33 as a pivot element and continuously do it on this array and then 78 on this right side part of the array and then sort it out. Or some programmers, after finding the pivot over here, may use any other simple sorting technique like a selection sort to sort it. But we can recursively apply, we can choose this first element as a pivot and then recursively apply the quick sort algorithm to sort the elements. Now what are the advantages? It uses only one small auxiliary stack. It requires only n log n times to sort an element, so the time complexity is n log n for the quick sort. It has an extremely short inner loop, that is, inner loop continuously works on a recursive function. Now what are the disadvantages of a quick sort? It is recursive, so if we try to implement without recursion, then the implementation is extremely complicated. It requires n square in the worst case of my complexity, that is, if I need to sort the elements, and then the n square is the worst case complexity for my quick sort. So quick sort uses recursion and a pivot elements to sort the array in a particular list of elements. It is fragile, that is, a small error during implementation can cause it perform badly. So we have to be very careful while implementing the quick sort. Thank you.